In this lesson, we will model a baluster family. I like to call them spindles. Revit doesn't provide too many spindles. There could be literally thousands of different types that we could model. For this exercise, we'll stick to a simple spindle family. The objective of this lesson is to first, find the right baluster family, second, to create the reference planes and parameters, and third, to model the 3D revolve. To get started, open your Revit file called Landings and Railings and follow along. The first thing we need to do is start a new family. So click the Program button, the purple R in the upper left-hand corner, and go to New, Family. The template we're looking for is simply baluster. Click Open. This family was specially made to perform on stairs or on a flat railing. The top angle cut will respond to the slope of the stairs as well as the bottom angle cut. The baluster height is adjustable as well. To get started, let's create some reference planes. In the project browser, drill into the Views, All, drill into Floor Plans, and double-click on Ref Level. What we need to do is create 4 additional reference planes to control the size of our spindle. The first thing we do is go to the Create tab and click on Reference Plane. On the Draw panel, click the Pick Lines button. Let's offset them 1/2 inch. Let's offset one to the left. Let's offset one to the right. Let's offset one up. Let's offset one down and hit Escape. On the Measure panel, click the Align Dimension button. Add 2 equal dimensions at 1/2 inch and pick off of the line. Scroll up until you find the EQ button and pick it. Add an overall dimension and place it above the reference planes. Repeat the procedure for the horizontal reference planes. Pick your first line, pick your second line, then pick your third line, and then click away from it. Click the Equal button. Now let's add the overall dimension from the bottom to the top, off to the side, and hit Escape a couple times. Zoom out till you can see both 1-inch dimensions. By holding down the Control key, select the 2 dimensions, and let's add a parameter to them. So click the Label drop-down, go to Add Parameter. Let's just call it Thickness. For this parameter, we're going to make it a type. If you think about why, the type parameter, as we know, will change the instance of every single spindle in the entire model. So therefore, every spindle in a staircase is going to want to be the same. So if we change a value in this parameter, we want it to reflect every spindle on that stair. Click OK. In the project browser, let's go to Elevations, then let's go to Left. 2 things we need are a top cut offset and a bottom cut offset. Essentially what we're going to do is model our spindle past where it would typically go and then put a void extrusion in there to cut it off at the bottom of the railing. We do this so the family can adapt to any staircase that we're going to put it in. The procedure for doing this is to right-click on the top reference plane and go to Create Similar. On the Options toolbar, let's just put in 2 inches. On the Draw panel, let's click the Pick Lines button and offset a reference plane up. While we're still with the offset of 2 inches, let's offset the ref level down. The ref level is where the base of the floor is going to be, or the bottom of the stairs. Let's add some parameters. On the Measure panel, click the Align Dimension button and dimension the top offset. And let's dimension the bottom offset. Be careful that you're going from the bottom to the top and from the top to the bottom. The reason for this is if the baluster height moves up or down, we want that 2 inches to move up or down with it. Hit Escape a couple times. With your Control key pressed, select both the 2-inch dimensions and let's add a parameter by clicking the Label drop-down and going to Add Parameter. Let's call it Cut Offset. We'll keep it a type parameter. Hit OK. There we go. Hit escape a couple times. The next part is to create what's called a revolve. That's going to be the main body of our spindle. We're going to go from the very top to the very bottom, and we're going to revolve it around an access point. To create the revolve, go to the Create tab, and then click the Revolve button. When it asks for a work plane, let's pick the plane called Center Left Right. Click OK. The next thing we need to do is specify an access line. We do that to tell Revit that this is the line we want to rotate our solid about. Click the Axis Line button. Draw a line from the intersection of the angled reference plane and the center reference plane down to the bottom angled reference plane and the center reference plane. Hit escape twice. Now we're going to add some boundary lines. If you click the boundary line button, select the line button and follow along. What we need to do is only specify half of the item, and then Revit will revolve the rest. So we're only looking at the center line and over to the left. So pick a point right here. Pick another point right here. Come down 5 inches and pick a point right here. The next thing we want to do is create a little arc. So on my draw palette, I'm going to click the Start End Radius Arc button. I'm going to make it a 1/2 inch. Move your cursor to the left until you see that 1/4 inch show up. Pick it. I'm going to draw another straight line that's going to extend a 1/4 inch. I'm going to hit escape. By picking a window starting from left to right, select all the magenta lines you just drew. On the Modify palette, click the Mirror Draw Access button. Zoom out and pick the midpoint of the center line axis and draw a horizontal line over to the right. Hit escape a couple times. Click the Boundary Line button, and let's add a Start End Radius arc. The first point is going to be the end point of this long line. The second point is going to be the end point of this line. And let's draw an arc with a 12-foot radius. To do this, you just type in the 12. You won't be able to see it because it's off the screen to the right. Type 12 and hit enter. Hit escape twice. The next thing to do is to close the shape off. On the Draw panel, click the Line button and draw a line all the way from endpoint to endpoint. Click the Finish button. With the revolve completely closed, it's time to click Finish Edit Mode. Revit will create the revolve for you. The next step is to provide the cutoffs like I mentioned earlier. It's funny because spindles are just like construction. We have to physically cut the top and the bottom off to fit them to the railing. Revit's the same exact way. To do this, go to the Create tab and go to Void Forms, then go to Void Extrusion. To specify a work plane, let's go with a name, and let's select Center Left Right and hit OK. To create a void extrusion, what we want to do is, on the Draw panel, click the Pick Lines button. Make sure the Lock button is checked on. This will ensure that when the staircase flexes around, our void will flex with it. I'm going to pick this line, this line, this line, this line, and that's it. Hit escape a couple times. On the Modify toolbar, click the Trim button. To trim, you want to click this line, then 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 this line, this line, then this line. This will trim up all the corners nice. Just remember when you're trimming, you always pick the lines you want to keep, not the lines you want to remove. Hit escape a couple times. Let's move to the bottom and do the same exact thing. On the Draw panel, click the Pick Lines button, no offset. Let's make sure our lock toggle is pressed on. Click this line, this line, this line, and this line. If you get a warning saying that highlighted lines overlap, that's okay. When we trim it, we'll fix that error. If you get it, just simply close out of it. Hit escape a couple times. Use your trim extend to corner icon, or as you can see, it says TR in parentheses. You can type that. That's a shortcut as well. Pick this line to this line, this line to this line, this line to this line, this line to this line. Once you have them in there, you can finally click Finish Edit Mode. It won't look like it's doing anything because you just have to make one plan view adjustment. In the project browser, go to Ref Level Floor Plan. You'll see a little line in the middle. Hover over it and select it. That's our void extrusion. It'll expose little grips. Take the grip and stretch it all the way over till you get to the nearest line and let go. Once you do that, you'll see a little padlock icon. Click it. Do the same for this line all the way over here. Stretch it all the way in. Once you see that nearest show up, let go and lock it. On the Quick Access toolbar, click the 3D icon. Our spindle's been made. Click the Save button and save it into the directory where you've been keeping everything else. Let's call it Spindle. Click the Options button. Let's set the maximum backups to 1. Click OK. Click Save. One last thing we need to do is select the spindle itself. In the Properties, go to Materials. Click in the By category. Don't click the small Builder button, but click the slightly larger button to the right of it. Click Add Parameter. Let's call it Spindle Material. We want to keep it as an instance parameter. Click OK. Click OK. Hit the Save button. It's not a bad spindle. Notice all the procedures for creating these families are always the same. As you can see, we're gaining a lot of control over the aesthetics of our stairs. By starting with the right template, then adding reference planes, parameters, revolves, and voids, we have a spindle that can go on any staircase.